Welcome everybody. Today we want to talk about the famous pet clinic, this time on Quarkus. Why we do that? It's because we want to talk about automated branching, and therefore I just needed a demo app. So why not use the pet clinic? You maybe also knew it as a demo app for Spring. We use a Quarkus version. So what can we do? We can search for owners in that app, and if there are not the owners we need, we can create an owner. So whatever we use. And a new pet. So maybe we have something. Oh. Okay. But so here we have our new owner. Okay. Why we do that? We do that because we want to see that if we create a new testing environment for a new feature branch, we have our original data and not the data we used in another test we had with our development branch. So what we talk about is how we can automate branching with GitHub Actions and Rancher Fleet. And what I will talk about is first just the basics about collaboration, branching strategy, then what is GitHub Actions and why is it useful to use a service like GitHub Actions, and then what is Rancher Fleet we have in our Rancher package, and then how we can use that tools to provision a full environment with a single click. So I'm Harold Gerhards. I'm head of cloud engineering at Infologistics and lecturer for cloud native computing at the University of Applied Science in Würzburg. And I'm a Rancher operator since 2020, so one of the Rancher partner from the older time. We at Infologistics are a SUSE Gold partner, and as our identification as a Kubernetes organization, we founded KubeSpectra with my KubeSpectra team, where we focus on open source software, Kubernetes, and also Rancher. So when we develop software, we normally don't do it alone. We work together with some other people, and therefore we have to manage how we can do it in parallel. That's the old problem we solved with Git. And in Git, we have not just our versioning, we also have our branching. So what we do when we use branching, we can develop in separate branches, and then we merge it together later to get our new version, and then we can release that version, and maybe we also have to fix it. And to do it, we need a strategy to know how to do it. And normally there are two possibilities how to do it. We can do it in the more old and stable fashion, which is Git flow, or trunk based, which would be the more cloud native option where we just have short living feature branches then merging into main and deploy it. But for our example, we will look on Git flow. So in Git flow, it's the more stable way. We have not just main and features, but we develop on feature branches, maybe also longer living feature branches. So therefore, it's a good idea to have also a test environment for that feature branch. And if we finished the work on our feature branch, we merge it back to develop. And if it's a good result in develop, then we merge it into master and make a new release. And also we have the possibilities to have hot fixes. So just to conclude that point, we need that branching to do our software development. We need rules for that and therefore a branching strategy. And if we want to do stable programming and stable releases, we could use that Git flow strategy. So then we should use it and create a branch. Yeah, we want to create our super feature. Okay, we created a branch. That's not new. But what is now running in the background is a create workflow. And our create workflow will create our test environment and our databases around. And so we can directly test it without any further action. But what is it? What we are now looking on, it's GitHub Actions. And therefore, I will just shortly introduce GitHub Actions. So what does GitHub Actions do? It's a continuous integration and continuous deployment tool. So just to have a look on our development lifecycle, we have our inner loop, so our local programming and local testing and debugging. We do our commits, and if we're happy with what we committed locally, we push our committed changes to our code repo, so normally to our feature branch. And then we can build our new container image with our continuous integration pipeline. We can do the tests, we can deploy it to our test environment, and later on we can also deploy it to our production environment. From our production environment, we get the data back from our monitoring and diagnosis, and with that results we can go back to our local development. So just the normal way. So why could we use GitHub Actions instead of just cloud native tools like Tekton? With GitHub Actions, it's very easy that we can just go from our repository and start the actions there, and we have our status of our GitHub Actions in our repository. We can directly integrate it without extra effort in our pull request workflows and so on. And what we can do, We can use it for all environments. We can use it also with parallel steps. We can use it for any programming language. And we have a great marketplace with many community-powered workflows where we can just use workflows other people built before, or we can use it to customize it for our use, and therefore we can get quick results. So, just to summarize, GitHub Action is just user-friendly. It's easy to use. You have its community-driven marketplace, and it's fully integrated. You can have your overview directly in your repository. Then comes our next component in. So, with Rancher Fleet, we have a GitOps component, but what is GitOps? GitOps just means that you use that DevOps best practice also for infrastructure, so that you're not just pushing your code with a pipeline to your deployment, but you also can use infrastructure as code, and for that you use also your version control. You can do it with the same collaboration tools. You can have the same compliance checks, and you also can use your CI/CD tooling. And with that GitOps, you bring it together, infrastructure management on the one hand and application development on the other hand, and therefore you can enable elastic environments which fulfill the needs of your continuous delivery. So it's just that simple in a nutshell. You have not only your application code, you have also your configs. So on top of Kubernetes, you have your configuration, and you can also have your infrastructure as code, all in the same manner with Git as a single source of truth. And therefore, you can do it fully automated and with quick releases. So, as I mentioned, the main components are just the same. We have in our DevOps model, we have our Git repository, we then have a build and testing pipeline, we have a deployment tool. Why we have that deployment tool? Because with GitOps we normally in the Kubernetes world use an operator, and that operator is pulling the changes, and it's not a push mechanism where a pipeline is triggered by the repository and pushes code to the cluster, but the operator is looking if there is a change between the state in your application cluster and your code in the repository. And if there is a change, the operator runs and changes it. And therefore, the fourth part, monitoring. You monitor your whole environment so that you can also see if you have the performance on the one hand with the operator and on the other hand just for your application. So what is Rancher Fleet? There are some GitOps operator on the market. So most popular is Argo CD. The other would be Flux, but they are both not GitOps at scale. But if we use SUSE Rancher, we normally not have just one cluster and one environment, but we have many clusters, many environment, development, testing, production, and then for different business teams or whatever. So to manage our fleet of clusters, we have Rancher Fleet as a GitOps operator controlled from our Rancher upstream cluster, and then configured for all our target downstream cluster. So what does our workflow looks like if we use Rancher Fleet? We have our development team. Our development team is creating the changes. We have our reviews, and if we check it into our branch, which should be deployed, then we have our build process, the image is built, we have our configuration, and our GitOps operator is looking on that configuration, takes the images from the registry, and can deploy it to so many clusters as you want. Not the full story, so it's normally limited to 120 clusters, but you can do a fleet of fleet, and then it's possible to have also about 3,000 clusters or so. The Rewe Group in Germany does it for their supermarkets. So with Fleet you have a very powerful tool to manage big fleets of clusters. So how is that Fleet working? To go a bit more in the details of Fleet. As I said, we have on our upstream, or on our Rancher cluster, we have our Fleet Manager, and the Fleet Manager has two parts. There is that bundle creator. So we will have a later look on the workflow, how it goes, but just to see the components of Fleet. There the resources are taken and they create bundles, and that bundles are then customized for the targets. You also can configure in your upstream cluster, centralized, and then you have the agents on the downstream clusters, which then deploy the bundle and also check for auto-reconciliation. So if you have a drift detection between your configuration in your repo and what is deployed on your cluster, the drift detection runs and you can reconcile it so that you can be sure that you always have the same state in your cluster than you have in your code repo. So how does the workflow goes? We're starting with our Git repo, but we can't see it there. The Git repo YAML is where you defined which repos should be watched by Fleet, and in that repos you then can create Fleet files to customize your installation for single targets. And then from that repos, bundles are created, and you customize that bundle with your Fleet file for the single targets and create bundle deployments, and with that bundle deployment then the Fleet agent will create a Helm release, and Kubernetes is then doing the installation of the Helm chart like it is defined in that Helm release. So what are our benefits of Fleet? It enables our full automated deployment. It brings us the scalability for GitOps, and we have that auto reconciliation and self-healing mechanism. So, but how can we use that to have our full provisioning? We just created a demo platform. So it's the the typical multi-cluster rancher structure. We have production and development clusters and our management cluster. We have our version management, and for the demo we did all that with a Google Cloud. We also used some specials in our monitoring and our observability stack. It's not just the standard stack, but it's a Grafana stack with Tempo for tracing and Loki for logging. But what you can see here, you have for each you have the branches in your version management system, and then for each branch you have an environment on the cluster. And you have also that Postgres database backend where you have also one database for each of your branches. So how can we bring Fleet and GitHub Actions to do that? For that, we not have just our app repo with our source code and our Helm config, but we have also a repo for our Fleet configuration, and in that Fleet configuration we have our Git repo artifacts, and if we create a new branch, we also create a new Git repo artifact, and our Fleet controller from the upstream cluster will then therefore create a new environment, new namespaces, new deployment, and GitHub Action will also provide us a new database, and we can then have a job running in our feature branch to bring the data in the database, so that we have with each feature branch new and unmodified data for our tests, to have it comparable between all feature branches. So how does it look like? That is what we already saw. We have our GitHub Action, and our GitHub Action is has a step that it's first creating the new namespace when we create the new branch, that it's then checks out the code for our application and so that we can deploy our application, and it will also create that Git repo artifact in the Fleet repo, so that Fleet looks on our app repo and will do the deployment, and on the other hand our action is creating the backend for our app. In the next step we also have that GitHub automation, and so if we push a change, then our CI pipeline will run, will build our image, will test our image. Then we can have our next component. In here we have new vector for our scan of the image, and if all is okay, it will be deployed in our new feature environment, so that we have not just the automated test and pipeline, but we can also have ourselves a look into our feature deployment and not only in our development. So if we are finished with our development, then we can create a pull request. For our pull request we have a secondary security check with new vector. Then we have possible compliance checks based on regulatory and company guidelines, and then the pull request to main is created. And if we merge our pull request, we have the next action, which is then just removing our feature environment and also the databases, so that we have nothing left from our test environments. Okay, so then we will have a look back on our environment. We saw our workflow, it's all good. Then we can also check in our rancher if there is all done. Okay, it's not all good. Why it's not good? Okay. It's a problem with our virtual service, but we fixed that. It's just that it's modified. So we can have a look if our application is there in our project Pet Clinic. We should now have two namespaces. So we have here our namespace named as our feature branch is named. And in our feature branch, we have our Pet Clinic. Yeah, and you see, okay, it's running since 7 minutes. We did it 17 minutes ago. There are that 10 minutes Google needs to create that database. That can't be quicker. It's a problem of Google. So with Azure, it's about 7 minutes. Yeah. So, but then we can have a look on our endpoint. Maybe it's running now. Yeah, you see here. We have also our endpoint with Pet Clinic, but then minus the branch name as the new endpoint. And if you are now looking here for our owner, you want to find Mr. Gerhardt and his SUSE lizard, you can't find him because we have just our fresh data as we had in our versioned code for main and not the changed data we had from our test we did manually. So just to have the other look, in our Google Cloud portal, we can also see now that where are our databases. Oh, we have a new database created from our workflow, and it's running. And we also see it's a bit smaller than the other with one line more. So then we can do not want to do yet some changes, but we could create a pull request. So we can merge it. And then we can delete the branch. So you can see here our branch is deleted, and we can see that here our deleting action is running, and it will clean up our cluster and also will clean up our database. So our database is gone, and if we look here on our, just go back, we see here our namespace is gone and also the workloads, so we have a clean cluster, and we can start with our next feature on the same clean environment. So, to conclude the whole thing, what I presented, it's in the end very easy because we have that easy to use and user-friendly tool GitHub Actions. We have that automation with Fleet, where we just need that Git repo component to monitor the single application repos. And we can also use Fleet to bring it at scale, because that bundles what are created within Fleet can be customized for many environments, for many clusters, so that we also can use it for cluster components like our monitoring, which is then deployed on all clusters in our whole cluster fleet. And if we then also use a possibility to contact a cloud API, then we can have that full automated also with back-end systems which are not part of our Kubernetes world. And that's not difficult to create, but it's very efficient for our development that we have that full automation in place. And so, therefore, thank you for your attention, and I think we have some time for questions left. Thanks. So there's a microphone for questions, so that your questions are also recorded. So then we start here.
Hello, could you please let me know if the modified config map or configuration in this design process require restarting the pod for the change to take effect? If you change the configuration at this workflow, you need to restart the pod to take effect.
I had just a problem to understand you, but with if I understood you right, we have now here a stateful app, so our changes in the database still remain. So therefore, we need that other environment if we want to have our clean data again and not just a restart.
Okay, so maybe I just feel because we have the something configuration management to restart the pod because we make a more change to configure the pod for like a deployment. So maybe we want to run the CI/CD flow, and then we want to enable the configuration take effect. So this is my problem. So I just to illustrate this scenario. If the GitHub action can take effect and without restart the pod.
So if you do changes and then the rancher operator is running, it will be also a redeployment with the new configuration. So it's not not possible to do changes during the runtime with that, or to bring the changes you did during the runtime back to the repository. That's not possible with that.
Okay, thank you.
I understand that GitHub Action is making some actions on Rancher and on Google Cloud to spawn a specific instance. How is the authentication of this action done, and where are stored the secrets, or is there any?
Okay, so what we did here is that we just did the creation of the database with a push mechanism from the GitHub Actions, that we go to the Cloud API and are creating it with a service account we created in Google. So secrets are in that example just created that they are also taken from GitHub and are deployed as a secret in Kubernetes. But there are many other possibilities, not so simple for a demo, but what we normally do in production at the moment is that we use an external secret operator and have our secrets stored in HashiCorp Vault, so that we are just creating external secret object with Fleet, and then the external secret operator is taking the secrets from the vault and is deploying the secrets to Kubernetes. The other point is you have other possibilities than just to use that GitHub Actions to create the database. The other option would also be the operator possibility, that you have also a database operator on your cluster, and that you're deploying custom resource with your Helm bundle, what Fleet was creating, and that then the database operator is creating the database for you. And that would also work the same way, that if Fleet is deleting the namespace and the custom resource, that database operator would also delete your database. And if you do it that way, you can do it all with external secrets, so that you are on the safer side. Yeah, I just mentioned that we can use more operators. The possibilities you have with that system I just showed in the simple scenario is you can deploy a full end-to-end test for your microservice system, and just create it, do automated testing in your real Kubernetes environment as a production reference, and also with new database and with actions on your database, and also on other managed services like PubSub messaging, and without any traces after deleting your branch. So that is what it makes this tooling so powerful.
See, what you have shown is how to create the complete application stack. You used some of the application component, other things can be added. Now, if you want to extend this to even create a Rancher management cluster, RK cluster, and some of the network connectivity, is there same tooling which can be extended with infrastructure as a code for the cluster itself?
So there are also, I would say at the moment, I see 3 possibilities to extend it to create infrastructure. So there is a operator possibility with cross-plane. So then you have can declare your infrastructure in that Kubernetes way, and then what also be the second way, cross-plane will run a Terraform workflow to create that infrastructure. The other possibility were to use directly Terraform, and the third way would be to use Rancher Harvester. But on that point, it's not possible to do that with Fleet, because Fleet is limited to do things inside the Kubernetes environment. But with that custom resource and then an operator like crossplane, it would be possible that you as a user of the platform are just using the Kubernetes native declarative way, and the rest with Terraform and so on is abstracted, that it's just done by the infrastructure team. That they are creating the modules, and you just describe that you want to have that module, and it's running automated for you.
Maybe to add to this, first of all, we are trying to make Kapi a first-class citizen, so the cluster API, and ideally you should be able to drive the whole deployment through Fleet, through Kapi, for either bare metal through the new stuff we are doing, at least for Edge with the metal cubed, so where we basically need a management bot controller, but then you can use Kapi, or of course Kapi has plugins for AWS and Google and so on. The other thing is, of course, if you want to start from scratch, you don't have Fleet yet. Fleet is part of Rancher, so there's always a bootstrap problem, a hen and egg problem. Of course, you can use one Rancher to manage other ranchers, and there, I mean, for bootstrapping, what we're doing in the Edge business unit, we have this Edge image creator where you can basically create a USB thumb drive, for example, on physical hardware that brings up your initial Rancher cluster, and it's all from this one stick, and then you go from there. So there are, I mean, Elemental would already, again, require a Rancher server, but the initial Rancher server, you can on bare metal bring up with this Edge image builder workflow, or of course you can just provision it. In the end you'll need something upfront, like one Terraform script before you have anything else. So I mean, there's always, you cannot use Fleet or Kapi before you have this first Kubernetes cluster that has Kapi installed and Fleet installed and so on. Or if you have a management cluster, and then have like other management clusters for your regions or so. I mean, that's possible. But the head management cluster, at some point there will always be a minimum of manual bootstrapping, I guess.
Yeah. So just to add, what we did at a customer is we had a bootstrap Terraform, what we have to do manually. And that was creating, at first, a GitHub action runner, so that all other infrastructure, also the Rancher management cluster, was then created using the Git mechanisms, and then it is created with a GitHub action runner. And if the management cluster is running, and also now without cluster API, our downstream clusters are also provisioned with Terraform. All what is on top of the clusters is then automated, deployed with Fleet. How is that done? One of the mechanism Fleet has for the cluster management is that you have cluster groups. Cluster groups are formed with labels. So if you create your new cluster with Terraform and they are labeled, they're getting automated part of the groups based on that label, and then all Fleet bundles prepared for clusters with that labeled are automatically deployed on that cluster, so that you can also create a self-service for your customers, that if they want to create new cluster and they take your template in Rancher or your Terraform module, that these clusters are directly provisioned with all your stuff on top, like service mesh monitoring and so on. So that's also the different to distributed GitOps system like Flux. With Flux, you had one Flux controller on each cluster. So you had another bootstrap process for that cluster. And with that centralized Fleet mechanism, you can directly provision your cluster components on top of the cluster without that extra bootstrap server for another GitOps tool. Yeah, so other questions, comments? Okay, not at the moment, so thank you. Have a good way back from SuseCon, or maybe see you in the next hour we have here. So, goodbye.